Here in 11.3, we're going to take what we learned when we were learning about the quadratic formula in 11.2, and we're going to kind of go a little deeper into that. We're going to look at some of the implications that we were hinting at and toying around with a little bit in 11.2, and we're also going to talk about quadratic equations in sort of a backwards fashion. So we're really exploring the idea of quadratic equations as far as we're able to in here in 11.3. So first of all, one of the things you may have noticed in our previous section was that there are different types of answers you can get out of the quadratic equation. Sometimes you get equations that have roots in them, and sometimes the stuff inside the root comes out really nice and you don't actually have a root in your answer. Sometimes the inside of the root comes out negative, which means you get complex numbers. Sometimes the inside of the root comes out 0, which means you don't actually get two different answers, you only get a single one. So in all of those cases, the thing that really makes a difference is this part here. This is the key part of the quadratic formula that controls the type of answer you get at the end. Does it have a root in it or not? Does it have a complex number in it or not? So this key part controls type. What kind of answer are you going to get? For example, if this part of the equation comes out less than 0, remember what less than 0 means. Less than 0 means negative. So if it comes out negative, then you're doing a square root of a negative. So if you've got that, what you're going to get here is complex answers. You'll get two answers. There will be plus something and minus something, but they will be complex answers. What that means is with I. So that's one possible thing that can happen. Honestly, though, how often does that happen? I mean, all the quadratic equations you saw back in Algebra 1 and all the ones we've been doing here in Algebra 2, you don't actually see those that often. That's kind of artificial. That's because of the way people write textbooks. We're trying to go easy on you. Usually what you see is the inside of that root there comes out bigger than 0. And in that case, you get two regular, everyday, what we call real answers. I'm going to put that word in quotes, though, because people misunderstand what that means in a math class. In the everyday world, real is like real versus pretend, real versus fictional. Like there's real things and then the other things aren't real. But in math, that word has a very specific meaning. What it means is there isn't any square roots of negatives in it. And it's called real for historical reasons, but please don't be distracted. That's not an actual meaningful word like you might think it is. And then, of course, if we're considering what happens if it comes out less than 0, what happens if it comes out greater than 0, you have to consider what happens if it comes out exactly equal to 0. You know, halfway between less than and greater than. What happens if it's sitting right on the fence between? So what happens then, we talked about that in 11.2. That means you get a square root of 0, which means you're doing negative b plus 0 over 2a and negative b minus 0 over 2a, which is really the same thing just said twice. So in that case, you get one answer instead of two. So here are the kinds of questions that you're going to be asked here in 11.3 that are related to this. And what you have to learn here is read the directions carefully, because they're not asking you to do what you think you're being asked to do. Like if you take a look at these four equations here, you might run into something like this in 11.3. You look at them and your instinct is, oh, I'm supposed to solve them. But if you read the directions, you'll see that the directions are not telling you to solve the equation. Don't tell me what x is or what a is or j is or k is. What they're asking you to do is to tell them what type of answers there are. So all you have to work out in each case is figure out the b squared minus 4ac part. Just that part. So here, b squared is 64. Minus 4 times a times, watch out for the minus sign, c. If you didn't have that minus sign, you get a really different answer out of this. So you end up doing 64 plus 80 equals 144. Now that's bigger than 0. What does that mean? Let's scroll back up, see what the rules were. Bigger than 0. There are 2 real answers. So what you'll be typing into the computer is they'll have 3 little bubbles to pick from, and one of the bubbles will be 2 real answers. So just click the appropriate bubble out of the 3 choices you have available. Now there's actually an extra thing that this is telling you here if you think a little bit more about what we talked about in the previous section of the book. 144 should kind of set off some alarm bells in your head. 144 is a perfect square. That's 12 squared. And since this is the number that's lurking inside of the square root, what that means is this square root is going to simplify entirely away. Our answer is not going to have roots in it. What that means is this polynomial factors. So there's actually a second conclusion you can draw here. The homework is not going to ask you to draw that conclusion, but that is a conclusion that logically is lurking in there. Okay, let's try this next one over here. Might want to pause the video, see if you get the same answer I get. So b squared is 25, 4 times a times c, that's 8. 25 minus 8 is 17. That's not a perfect square, which means this thing wasn't going to factor, it was hopeless. But it does mean that there are 2 real answers. Have you done these other 2 yet? If not, go ahead and take a second, pause the video, see if you get the same results I'm about to get. Okay, so b squared minus 4ac comes out to be exactly 0 here. So this is one of those situations where you get only a single answer. And it's going to be an answer without any square root in it, because square root of 0 is 0, so it also factors, so it also tells you that. This one over here, b squared minus 4ac comes out negative 16, and because of the negative, that means we're going to have 2 complex solutions. So this part of the homework is pretty straightforward stuff. You do a little computation, and then you click one of 3 possible answers. You'll probably, once you understand the arithmetic side of it, you'll probably move through it pretty quick. There is a second thing that we're going to do in 11.3, and this one's kind of important because it requires us to think about things in reverse. Here, we're going to be talking about creating equations from the answers you want to have at the end. So really what you need to do here is remember all the quadratic equations you've solved in the past. Those ideas should not have just vanished from your brain as soon as you were done with them. They were supposed to sink in a bit. You were supposed to learn stuff from that and sort of get an instinct about these things. So, for example, when you say the answers are -1 and 3, I probably would not have gotten that from the quadratic formula. That's too simple of an answer. I probably would have gotten that from a problem that I factored out. And if I'm imagining this being the end of a factoring problem, I imagine that a moment ago it was actually probably 2 equations. One of the equations ended up with an answer of -1, and one of the equations ended up with an answer of 3. And that probably happened because this equation said x plus 1 equals 0, and this equation said x minus 3 equals 0. That's probably how I got there. And how do we typically, when you're factoring, how do you end up with 2 equations? Well, it's because you had one equation and then you split it in 2. So this here probably came from something that looked like this. And usually they don't give you the equations already factored, so it probably didn't look like this at the start of the problem. it probably was all multiplied out to begin with. It probably looked like this in the beginning. So notice that what you're expected to be doing here is remembering how problems have worked in the past. If you've only ever worked one or two problems before, you can't really do this kind of thing. This is only something you're going to be able to do if you have enough practice to where you are truly familiar with what you're doing here. This is part of what you're supposed to be learning in math classes, not just barely getting through a topic, but building enough experience with the topic to where you're actually familiar with what you're doing. That's going to be even more important with this one on the right. Because, again, like what we had over here, this probably came from two different equations. There was probably one equation that ended with this, and there was probably a second equation that ended with this. But I'm pretty sure that the equations that produced this, they probably did not say this and this. Because I don't recall when I've been solving quadratics in the past, when I have done my factoring, I don't think I've ever factored something and made it look like this. That's completely unfamiliar with me. I've never seen that before. So, that's probably not what happened. Instead, we have to think back, did I ever get fractions in the past? And the answer better be yes, because you definitely have seen quadratics that ended with fractions in the past. How did they end with fractions in the past? And if you're not sure, go back and look in your notes. Find some equation that you've solved in the past where you end up with fractions and see how did you get there. And I bet I know what you're going to see. You got there by dividing. You actually had 3x equals negative 2, and then you divided by 3, and that's how you got a fraction. Or you had 5x equals 3, and then you divided by 5, and that's how you got a fraction. That's a familiar thing. I've seen that before. And this could easily have come from something like this. This one over here could easily have come from something like this. And that could have been created from a pair of factors that look like this. And of course, multiply it out because you've never really started with them already being factored, hardly ever. They're usually starting out already multiplied out, like this. And that's the kind of reasoning we want you to do. We want you to go back into your memories or look back in your notes and see, when have you done something like this before? How did it end up there? And work those steps backwards to go back to the beginning. So that's a very tricky sort of a thing, but it doesn't really require you to learn new techniques. It just requires you to really understand your old techniques.